years. Angles curves, diamond swirls. Shapes I often have to observe. Make me dizzy, make me sigh. Geometry's one busy guide. Circles, squares, prisms, spheres, shapes that look like rabbit's ears. Hexagon gives us pentagon shapes. Polygons, yes, see, octagons, septagons, genagons, geometry. Now geometry gives us all our shapes. Yes, see. Well, can't you see? Geometry, trapezoid, geometry, fill a void. Oval gives us all our shapes. Don't forget the rectangle, spiral angle, true star wedge, even shapes that have no edge. Pyramid gives us all our geometry. Is who I am. Geometry, geometry, who I am. It gives us all our shapes, you see.
Well, welcome back, geometry students. Here we are with 1.3 from our Big Ideas curriculum. And we just saw that last installment of that geometry song. I know you were on edge, couldn't wait to get to the end of that song. Well, in 1.3, we're going to be looking at two different formulas. These are very important formulas, the midpoint and the distance formula. So that's our main thing we're looking here in this one. We're looking at coordinate planes, so that's going to be talking about an XY coordinate and ordered pairs. We'll be plotting some of those, working with those ordered pairs as well, as we try to use them to find the midpoint of segments and find the distance of segments. All right, before we get into that, let's do a little quick cartoon, a little Far Side cartoon. It says, suddenly a heated exchange took place between the king and the moat contractor. So you can see there, wait, I told you outside the gates, outside the wall. They're building the moat on the inside of the castle. All right, so as we get into our geometry now, first thing we look at is some vocabulary. Now this is in your book on page 14, so you don't have to write these down, but just highlight the vocabulary here in this core concept. We're seeing midpoint, segment, bisector. So the midpoint, here's what a midpoint is. The midpoint of a segment is the point that divides the segment into two congruent segments. It's right there in the middle. Midpoint is a point that's directly in the middle of a segment, so you have segment AB. You know, M is going to be, if M is the midpoint, then M is going to be right in the middle, and you can see the little congruent marks divides it into two equal segments there. And it gives you some, different ways we could say this. M is the midpoint of segment AB, so segment AM is congruent using that congruent symbol to MB, segment MB. And there's another way you could say that AM is equal to MB. That would be the length in actually the number form. So we would say the segments are congruent, but we would say their lengths. If I just wanted to say AM with nothing above it, that's talking about the length, which would actually have a coinciding to a number of how long that is, which if we needed to measure it or whatever we needed to do. The segment bisector, okay, here's what we want to know for a segment bisector. Similar to the midpoint, but instead of just being a point, a segment bisector is a point, ray, line segment, or even a plane that intersects intersects the segment at its midpoint. So basically, you have your midpoint. If you're going to have something that's going to go through that, and now the point there, that could be a segment bisector as just a point. But this one is showing actually a line going through it. You can have even a plane go through this, and that could be, if it's going through the midpoint, then that could be a segment bisector as well. Or a ray, we could just have it going this direction and not have the bottom part and just have a ray MC, and that would be a segment bisector. So different things could become segment bisectors. It says a midpoint or segment bisector bisects the segment. So again, it is making it into two congruent segments. It bisects it right there. So line, CD is a segment bisector of segment AB. And so the same things are true, as you can see, with the midpoint as with the segment bisector down here, with the segments being congruent and their lengths being equal. All right, moving on. Okay, so on page 16, we're going to begin our extra practice, 1 through 3 here. It says, identify the segment bisector of segment AB, then find AB. So that means we want to find the length of the segment. When it says find AB, how long is it? And that would be a number. So in number 1, we'll go ahead and work on these together. We want to do two things here. It says, first, identify the segment bisector. So I'm going to call that A, And then second thing is find the AB, the length of that segment. And I'm going to call that B. So for A on this one, the segment bisector is just the point. So it's just a point on this one. So we would just call that point M. So that will be our answer for A. Point M is the segment bisector. And we could see that there, remember segment bisectors, this means that each of these sides are exactly the same. They show a little congruent mark. So if this is 13, we know this side is also 13. So segment addition here, you can just say 13 plus 13 then will equal the longer segment of AB, which there would be 26. So there's our answer for B. Go ahead and pause the video now and do 2 and 3. So do A, which would be identify the segment bisector, and then do B, which is find the length of that AB segment. And then go ahead and play it after you finish 3. Okay, hopefully you did number 2 and number 3 on your own, and then you can just check your answers. So for A, our segment bisector here is going to be a ray. So that's going to be called ray MC. Now I wrote the word ray down here. You don't actually have to write the word ray. When you write the word point, you know, if it's a point, usually we like to say the word point, but I actually said the word ray. And there's MC for that one. You can't say CM because remember it's going the direction of the arrow. And if this is 8, then the other side is 8 as well, so it's 8 plus 8, which is 16 for the length of AB. On this one, we have a line going through our midpoint, and so it's going to be line L on that one, and we definitely want to use the word line here if we're naming it with what the name is. That's going to be line L. This is side's 26, that means the other side's 26 also. 26 plus 26 equal to 52, so that's what we should have. All right, let's go down to number 4 through 6. Again, we have 2 things we're trying to find here as well. Identify the segment bisector of EF, which is exactly the same thing we did there. Okay, so we're doing the same thing for the first part. Then find EF, which EF is the longer segment here, which is the same thing. Now, except the only difference is, notice, instead of giving us the number, now they're going to give us a little expression. Now, I've been warning you about this, that this is what they're going to do. We're going to have to make an equation eventually and solve for x. To figure out what x would equal, and then plug it back in here to our expression to see how long each side is going to be. All right, so starting with number 4, we can see here's a ray. So our going through, there's our point M, the midpoint, but we have a ray is the segment bisector. And so we want to name that ray. We can say MT. It's got to go that direction. So we have A and B. So again, this is my A. I'm going to do A first, which is just ray MT. I didn't write the word ray this time. I just put the ray MT. And then for the B part, for B, we're going to say since these are both equal, okay, they're congruent, we can set these two expressions equal to each other. So 6x is going to equal 2x plus 4. Just like we saw these were equal to each other. And so it's going to be 6x is going to equal 2x plus 4. Just now we can subtract 2x to solve for x. And so it's going to give us 4x is equal to 4, divide by 4, so we could find that x equals 1. So if we know x equals 1, and we plug 1 into 6x, that just makes this side 6 over here. So if this side is 6, the other side is also 6 as well. So they're both 6, which means that EF is going to be 12. All right, so go ahead and try, well, let's do 5, and then I'll have you try 6 on your own. Let's go ahead and do 5. Which we could see the bisector right there is the line, and it is just line M, that little lowercase m right there, so line M. And then we're going to set each of these equal to each other. So we'll make our equation first and then solve the equation. So x plus 15 is equal to 7x minus 3. Let's get the x's to one side. I'm going to subtract x from both sides. That way I keep my variable term positive. And so if we have 15 on this side is equal to 6x minus 3 on the other side. And then we just want to add 3 to both sides to get the 6x by itself. And so when we do that, 3's canceled here, and 15 plus 3 is 18 now on the left side, equal to 6x. We just have to divide by 6 to solve for x. And so when we do that, 8 divided by 6 is 3. So x equals 3 on this one. So as we plug it back in, you only have to plug it into one of these really, because they're both exactly going to give you the same thing. So I plug 3 right here. 3 plus 15 is 18. So I know that side's 18. I know the other side's also the same because they are congruent. They're equal. So 18 plus 18 is going to give me 36 for the EF. All right, go ahead and now pause the video, and then you do number 6, and you can play it and see if you did it correct. Okay, hopefully you finished number 6. For A, it is just the point. Point M is our segment bisector on this one, so it's just the point. And our equation is going to be the 3x minus 4 equal to 5x minus 12. So we set that up, and then we start to solve by getting the x's on one side. So I'm going to subtract 3x first from both sides. Cancels them here. I have 2x now on this side. So negative 4 on the left is equal to 2x minus 12. And now I'm going to add 12 to both sides to get the 2x by itself. So I do that. And negative 4 and 12, it's going to make a positive 8. So 8 is going to equal 2x. If we divide by 2, 8 divided by 2 is 4. So x will equal 4 on this one. If I plug it into this one on this side over here, 3 times 4 is 12, and 12 minus 4 is going to give me 8. So if this side is 8, then the other side we know is 8 also. 8 plus 8 is 16 for the segment EF. So a little segment addition to find the whole segment. All right, let's move on to the next part. Okay, before we get to that next part, let's do a quick joke of the day. So where do pencils go on vacation? Or where do pencils go for vacation? Well, of course, they're going to go to Pennsylvania. Pennsylvania. I think the Liberty Bell is there. All right, so on page 15, our next core concept. Now here's where we see the midpoint formula. So we already talked about what a midpoint is. It's going to bisect the segment. It's going to be right in the middle of the segment. So if you're looking at a coordinate plane, here's our x-axis and y-axis, you have 2 points on there, A and B. And if you know what the midpoint is, M, right here in the middle, we could figure that out with a formula here. So you have point A is an x and a y point, and they're going to call it x1 and y1. Point B is going to be x2 and y2. So basically what we could do here is we could take these x numbers here of the A and B, add them together, and then just cut them in half, divide them in by 2, and that would give me the x coordinate for point M. And I could do the same thing with the y's. I could add the y's together and cut that in half. That's going to give me the y coordinate for point M. Okay, so you can kind of see how that's working out. You know, for x1, so here's where x1 is, and x2 is over here. M is right there in the middle, which would be adding those together, dividing by 2. Same thing up on the y. y1 is here, y2 is up here. So if you add them but divide by 2, it's going to put it right there in the middle. And that's going to give you your coordinates for point M. That's what we're trying to find as a coordinate. Now for point M, if we know the ordered pairs for A and B, we can find the ordered pair for M using the midpoint formula. So here is the formula right here. You may want to highlight that part right here on the core concept. That is the formula x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Notice it's in a parenthesis because it's an ordered pair. Now we have the x coordinate going to be right here, comma, the y coordinate for our midpoint. Okay, so back on the extra practice, we're on page 16. 7 through 9 are saying that the endpoints of PQ, so think about a segment on a coordinate plane, are given. So you have a segment and the endpoints are labeled P and Q, and they're given by these ordered pairs. It just wants to find the coordinates of the midpoint M. So what would be the coordinate of the midpoint of that PQ segment? So number 7 here, we're given our numbers, we're going to use our formula. Now remember the formula, it's a very simple one to remember. So you just got to first think of it as just an ordered pair. So one big ordered pair. We're going to add the x coordinates together, then divide by 2. So we have an x coordinate of negative 4 and 0 in these two ordered pairs. So the first part is just negative 4 plus 0 divided by 2. That's what the first part of the formula is for the x coordinate. I'm going to put a comma, and now we'll do the same thing for the y numbers of these two ordered pairs. We got a 3 and a 5, so it's just going to be 3 plus 5 divided by 2. And now all you have to do is just simplify that down to a single number, or it could be even a fraction as well. But in this case, we're going to get negative 4 plus 0 will give us negative 4 over 2. And on this one, 8 plus 5 is 8, 3 plus 5 is 8, so 8 over 2 on the y. And now each of these are even, so we're going to get nice easy numbers here. Negative 4 over 2 is going to give us negative 2. This will give us 4, so our midpoint is the ordered pair, negative 2, comma 4. See, it's not very hard at all. Let's do our number 8. So we're going to look at our x numbers first and add them together. So negative 2 plus 10 divided by 2. So we'll write that down first, then comma. And then we're going to do the same thing for the y's, add the y numbers together. 7 plus a negative 3, and then we'll put that over 2. 7 plus negative 3 over 2. And now just simplify the top. So if I take 2 away from 10, that really gives me 8 over 2 on this one here for the x. And this one's 7 minus 3, so take 3 away from 7. That's going to give us 4 over 2 on the y. And this is going to give us now 8 over 2 is 4, 4 over 2 is 2, so 4 comma 2 is the point for our midpoint. That's the coordinate for the midpoint. Alright, so I want you to pause the video now and try number 9. Do the same thing. Use that midpoint formula to find the coordinates of the midpoint. Alright, so hopefully you got a coordinate for the midpoint. Let's just check to see if you got that right. So you start with the x's, 3 plus 9 divided by 2, and then the y's will be negative 15 plus a negative 3 divided by 2. And so when you add these 3 and 9 together, you get 12 over 2 for that one. And when you're going to actually add the numbers here because they're both negatives, this is going to give you negative 18 over 2 for the y. So here you're going to get 6 for the x and negative 9 for the y. So your ordered pair would be 6 comma negative 9. Hopefully you got that correct then. Now down here on number 10 through 12, we're using the midpoint formula, but it tends to be a little more challenging because look what it says. The midpoint M and one endpoint of segment JK are given. So your segment this time is JK, the endpoints are J and K, and the midpoint is M. But you're going to be given the midpoint every time. So you're going to be given the midpoint. You want to find the coordinates of the other endpoint. We're still going to use the midpoint formula to do this, but it does tend to be a little more challenging. In fact, what we have to do is make an equation for each coordinate. We need to make an equation for the x coordinate and make an equation for the y coordinate. Okay, so for x coordinate, let's just talk about, okay, we got the x. I'm going to just put x here, and we're going to do that right underneath there, the x. So for the x, remember it's the two x numbers added together, but they're the two x numbers of the two endpoints. We don't know one of the endpoints, and that's going to be divided by 2, and it's going to equal the midpoint. So we don't know one of the endpoints. We have j, we don't know k. So we could say, you know, we have j, which could be the x right here. So here's my x for j, 7. So this is, we're going to use x right here and this x right here. So 7 plus the other endpoint divided by 2. That's using the midpoint formula, just like we did up here. We just don't know what the other endpoint is, so we got to use an x up in the fraction, and it's going to equal the midpoint number for x, which would be 1. So now we need to solve that equation. Okay, that's the equation we're going to solve here on this one. And let's try to do, actually I'm going to solve this first. Let's find out what x is, then we'll come back and do y. So first we got to get rid of the 2. We're going to multiply both sides by 2. So I'll multiply this side by 2 and that side by 2. Now we cancel the 2's out here. And now it just leaves me with 7 plus x is equal to 2. And so now we have to subtract 7 from both sides to find out what x is. And so it's going to cancel our 7's out there, and that's going to leave us with x is equal to 1. So there's our x coordinate, and we'll put that down here eventually when we get to the end. And now let's go ahead and do the same thing, but now for the y. So for the y this time, we're going to use these numbers, so the 2 and the negative 2. So here's our endpoint. There's the endpoint we do know is 2, plus the endpoint we don't know is going to be x divided by 2, and it's going to equal the midpoint number for the y is negative 2 here. So we start off by doing the same thing, multiply by 2 to get rid of this fraction. Multiply this side by 2. So it cancels out our 2's, so we got 2 plus x is equal to 4, or I should say negative 4. Negative 2 divided by, or times 2, negative 4. We just got to subtract 2 now from both sides, and so we find out that this time, actually I noticed what I did wrong there. Not a big deal, but I put x for my variable, and it should be y, shouldn't it? So let me just fix that real quick. That's bothering me. So this really should have been a y right there. So we're going to solve for y. So cancel those 2's out. Y is equal to negative 6. So our ordered pair answer here for this would be for point K. We don't know what K is. We're going to say, okay, K is the ordered pair positive 1 comma negative 6. That's our answer on this one. All right, let's go ahead and try number 11 here. We know J again, so same thing. Now you notice I put the number first, then the variable. You could have switched that. If you put x, then plus 7, you would have got the same thing right. That didn't really make a difference. So let's start with the x again. So doing x on this problem, we're going to start with this x number 5. I can say 5 plus x over 2. That's just the midpoint formula, and it's equal to the midpoint number in here of this x, 0. So I'm going to multiply by 2. Cancels our 2's out there, so 5 plus x is equal to 0. Subtract 5, and so now I can see, okay, here x is equal to negative 5. And then we'll put comma for the y. So comma, and we'll do y here. I'll do it in red again. And so we start off with the y number of our point we know, of the midpoint we know, negative 2. And we can say plus x, and that's going to be divided by 2 for the formula. And it's going to equal the midpoint number for the y, which is the negative 1. So we have to build this equation. We're building an equation here. Multiply by 2 to get rid of the fraction. So those 2's cancel. Multiply this side also by 2. Now notice up here, okay, I guess I should mention I multiplied this side by 2 and I didn't multiply the other side by 2. Okay, well, reason why I didn't do that, and I think I just kind of did that mentally in my head and I didn't say it, is that if we say 0 times 2, you're still going to get 0. So yeah, I probably should have written down right here that I'm going to multiply both sides by 2. Whatever you do to one side, do the same to the other, of course. But 0 times 2 is still going to give us 0, still going to give us that negative 5 for the answer on x. This time, though, we need to multiply this side by 2. So we're going to get a negative 2 plus x, and it's equal to negative 2 on the side. So when I add 2 to both sides to solve for the x, so negative 2 and plus 2 cancel out. Those 2 cancel out there. So we're going to see x is equal to negative 2 plus 2 here also cancels out and makes us 0. And again, look what I did there. I keep saying x, don't I? I'm just messing that up. Again, not a big deal, but we're solving for y on this one. I don't know why. I think I just get so used to when I'm solving equations, I'm solving for x, but I got to remember I'm solving for y this time. So there we go. X equals negative 5, y equals 0. That would be confusing if we had 2 x's. So now we can write out our ordered pair, which is going to say k is equal, or not should say equal to, I should just put the point there like I did before. So I'll just say k is the ordered pair of negative 5 comma 0. Negative 5 comma 0. There's our answer. That's what k is on that point. That's the other end point. Okay, so I'm going to give you a chance. Now try 12 on your own, and then you'll check your answer and do the same thing I was doing here. Make an equation for x, and then make an equation for y. Don't do what I did. Remember to use the variable y as you're making that equation for the y. All right, pause the video and then try number 12. Okay, so I started off, I wrote the equations down for x and for y, so you should have these equations. If you don't have these right equations here, then it's going to be wrong as you solve it, of course. So we start by multiplying by 2 on this guy right here, on our x equation. And yeah, I did it again, didn't I? On that y one. Sheesh. I just can't get that, can I? Now you guys are probably laughing at me right now. I'll make it blue so that makes it stand out. Okay, so now I'm back. No, I want to go blue. So multiply both sides by 2. So times by 2 there, and that cancels our 2's out on this one. Leaves us with a 2 plus x. It also cancels the 2's out on this one, leaving it with negative 9. And then we just got to subtract a 2 from both sides. So that gives us an x of negative 11. And for the y over here, go back to red, multiply by 2 here, cancels the 2 out. Multiply 7 times 2, so we're going to see a 16 plus the y is equal to 14. So subtract by 16 now both sides. So our y on this one, take 14 away, it's a negative 2. So our answer for k will be negative 11, comma, negative 2. So that's our answer for k. There's the midpoint. That's not the midpoint, the other endpoint. So what we just found with k, we found the other endpoint. So you got to think about that as we have a segment. So like if I said a segment right here, and we had j on one side, k over here, m is in the middle. So m is right here. We knew these two. We were trying to find that one all the time on this one. On this problem up here, we again had endpoints across here on our segment, which were P and Q. So we had P and Q as the endpoints, and M in the middle, that's the one we were trying to find up here on this one. So we just used the formula. It's a whole lot easier if you're just trying to find the midpoint. It's when you're trying to find the other endpoint that it makes it a little more challenging, and you have to do out these equations. Okay, so now on to the other formula, which is the distance formula. So go back to page 15, you'll see that core concept there. And you'll see again a coordinate plane showing you you have 2 points here, again A and B. And we actually are going to form a C point out here as well, kind of making a triangle. And we want to find the distance between A and B. And so we can see, okay, well, if you have that C out there, making a perfect right triangle, what you could do there is you could look at the distance right here for A to C, and you're going to subtract, basically the distance there is going to be subtracting the coordinate numbers of A and C. You're subtracting the x2 minus x1 of the coordinates. And you're doing the same thing when you're going from B to C here on the y, subtracting those coordinates for the y. Okay, so that's what we're doing there. We're basically using the Pythagorean theorem to work with those two things. So the formula to actually find the length of AB, notice it just says AB here, and you want to highlight this formula. This is a formula that's going to continue to come back over and over again throughout almost each chapter as we look for distances of things. We just have to always have that in our back pocket to pull out and use again. So you got to remember that and get really good at remembering what this is. So if we want to find the distance between AB, or the length of AB, it's a big square root. You're going to subtract the x numbers and square it, and add it to subtracting the y numbers and squaring it. And it really coincides with the Pythagorean theorem, as you can kind of see down here. Here's what's underneath is right here now, where you're subtracting the x's and squaring it, plus subtracting the y's and squaring it. And because what we could do there is we could get rid of the square root by squaring both sides, so we're going to square the AB. And so the distance formula could be this as well, but that really makes it just like the Pythagorean theorem, where it's like a squared plus b squared equals c squared. You should know that from previous classes, even in junior high school. They should have taught you that. A squared plus b squared always equals c squared on a right triangle, which we will get into further down the line as we work with right triangles, as it says here. All right, so I know there's no more problems. We're going to do some more problems for this distance formula. 3 more problems I want us to do on a different page in our notes here. Okay, so actually not on a different page. It was still going to stay on page 15, right where the distance formula is. You should have a notes section above it and below where that distance formula is. And just in those sections, I'm going to ask to do these 3 problems. So 7, 8, and 9. Basically, it's the same numbers that we saw from before when we did 7, 8, and 9 of finding the midpoint with finding the segment between P and Q. It's just now we're going to find the distance from P to Q on each one of these. That's what I want us to do. And I want us to find that distance in 2 different ways. One as a simplified radical, and the other way is going to be as a decimal. So we're going to get our answer in 2 different forms. All right, so to start with this, we need our distance formula, which you have there. We're going to start with just saying, okay, PQ. So PQ would just be, when you don't put anything above here, now we're talking about the length of PQ. How long is it? And so we're going to start with the x numbers. We're going to subtract the x numbers this time. So notice the midpoint formula is you're adding them, but now the distance formula, you're subtracting them. So and it's all under one big square root. So put a big square root sign here, and then a parenthesis with the x numbers that you're going to subtract. So big square root, first parenthesis has the x numbers and we're subtracting them. -4 minus the 0. And then you're going to square that eventually. So put a little square above that parenthesis. And then put the plus, and we'll do the same thing now for the y coordinates. We're going to subtract them, 3 minus 5 in the parenthesis, and then we'll square that number as well. So here's what we got to do. What's inside the parenthesis first as we start to simplify this down to a single radical, in fact. So we have a -4 when we do -4 minus 0. So that'll be a -4 under this one. That's going to be squared, so it's still a big radical. Now this is now -4 squared, plus in here as we take 3 away, it's going to be -2 squared in this one. So if we square -4, that's going to turn positive to +16. This will be turning to +4. So under the radical now we have 16 plus 4, which will be 20. So square root of 20, that's down into a single radical now, but we want to get a simplified form. So the square root of 20 is not as simple as we can get it because there is a perfect square factor in 20 of 4. So 20 could be 4 times 5, and now we can think of the square root of 4 is 2. So the simplified radical form is 2 square root of 5. Now remember us doing that on the review packet, where I was having us simplify radicals there. This is one reason why I wanted you to start to review that, so because we're going to use it here. Now, to get the decimal form, the easiest way to get the decimal form is go back to your single number radical here, the square root of 20, and then just use your calculator. So I'm going to go just put 20 in, and then hit the square root button, and there it is. I don't have to worry about it going from here. It's actually simpler to go back to here if I want to just find the decimal form. So if I want to go, let's see, like to 2 decimal places, remember we're going to round to do that. So 4.47 could be our answer on this one. 1 decimal place would be 4.5, depending on which decimal we want to do. On this one, let's go to 2 decimal places. So let's just say 4.47 for that one. All right, so problem 8, you're still on page 15. Find some more space in those note sections there. And so again, PQ equals, and it's going to be 1 big square root. And we'll start with the x numbers, -2 minus 10 in the first parenthesis. And we're squaring it. And then we do the y's. We're going to subtract these. 7 minus a -3. So we end up with a double negative in this one. 7 minus -3, the double negative turns positive. So now it's 7 plus 3. So make sure you realize that. So you're going to get some double negatives as you do the subtraction. Like this situation right here, 7 minus a negative. That minus a negative turns to a positive. And so now as we simplify this first parenthesis, that's going to be -12 in that one. So underneath the radical, -12 squared for the first one. This will be 10 squared for the second one. And -12 squared is going to be a +144. This will be a +100. So it's 144 plus 100. So our single radical is square root of 244. But again, that is not in simplest form. We want to look for the biggest perfect square we can find that goes into that. So if you want to start small, you could, like does 4 go into it? Now I'm sure probably something even bigger than 4 goes into this. You might try 9, you might try 16, and so on. So if we use a calculator to help us do that, I don't think 9 goes into this one. So if I divided it by 9, it shouldn't come out evenly. Oops, no, that's what I meant to do. 244 divided by 9. There we go. Yeah, so that doesn't work, but 16 I would imagine might work. So let's try 16 first and see. Divided by 16, and what do we get? Oh, no, 16 didn't even work. So we can try something even bigger than 16 possibly that might work. Maybe 36. I don't think 25. 25 is not going to go into that. So if we do 244 divided by 36, it's still not going to be that one either. So, you know, maybe it is just 4. You know, it's possible it's only 4 divided by 4 here. 61. So when I'm looking at 61, the number 61, there are no other perfect squares because I know for a fact that 61 is a prime number. It has no other factors other than 1 in itself. So with that one, 4 was the number you'd want to go to. 4 times 61, so it's going to be 2 square root of 61. So that's our simplest radical form. For the decimal, though, we want to go back to the square root of 244 and use our calculator. So 244, square root of that. Let's go to 2 decimal places again. It's 15.62 as we round to 2 decimal places. So there it is. All right, so go ahead and pause the video, and I'll give you a chance to try number 9. Use the distance formula to find the length of PQ with using these 2 points. Okay, hopefully you paused the video and now you've finished number 9 and you have an answer for that. 2 answers really, in radical form, simplified radical form, and decimal form. So what we see here on this one is 3 minus 9 in the first parenthesis, and then it's plus negative 15 minus a negative 3. Well, there's another double negative with minus the negative 3, so that becomes a plus 3 on this one. So for this one here, we will subtract the numbers and get negative 6 in the first one, negative 6 squared there. Here we're going to take 3 away from negative 15 and get negative 12 squared in that one. So we're going to get a positive 36 and then a positive 144. So positive 36 plus 144, that's going to give us 200 on the dot. Or sorry, not 200, 180. Misspoke on that one, 180 on the dot. So 180, we want to simplify that. We definitely know 4 goes into this. 36 would probably go into it as well. So the biggest perfect square that you should have found was 36. That went into that 5 times. And so the square root of 36 is 6. So 6 square root of 5 is the reduced simplified radical form. If you used 4 only, then you didn't simplify it as far as you should have. And then to get the decimal, you can go back and just use 180. And so we'll just hit 180 and square root and get our decimal form of that one, 13.4. On this one, the 6 is bigger than 5, so we're going to round this up to 4.2 for 2 decimal places. So round up on this one. So 13.42 is what we get here. All right, so that concludes our lesson on 1.3 with the midpoint formula and the distance formula. So you're ready to go on to the assignment, and I'll see you on the next lesson.